Hey guys, it's Vince. Today in this video, I'm going to go shopping with all of you. It's Labor Day weekend, and I know many of you will be doing this regardless. That being said, before we jump in, I've gotten asked so many times about the kinds of messages that I receive. Are they real? Do you really get a lot of people having problems with other systems? Here's one I've got, and this is just recently, August 29th, and this is my eBay store. I have a very frustrating situation with the CNC I tried to build that I bought the plans from a guy on YouTube called Homemade Madness. Remember him? I did a video on him. The machine doesn't work as he shows in his video. My question to you is, can I use your controller system on my already existing table? Also, would you be able to help through it? I look forward to hearing from you. Well, I guess I've answered the question, are these messages real? I'm going to make everyone aware if you send me a message like this, I will hide your name, I will hide all of your personal information, but these are going public from now on. That being said, it's really drawn me into going shopping with many of you because I've gotten asked in the last few weeks about a multitude of systems. And once again, had this gentleman took me up on my consultation prior to finding me now, he would have avoided this whole situation. Would he have had to pay me? Absolutely. But if you think about how much he's paying me, and I've said this so many times before, the little amount you pay me is worth the time, the money, the frustration, and the fact you have to redo everything over again in the event you follow someone's incorrect practices to build your robot. Think about it. Let's jump right in and let's look at a machine I've gotten questioned about over and over again. Apparently, smaller size CNC chassis are becoming more and more popular, and I totally agree. They should be. Honestly, size of your products do not dictate price. Case in point, a Rolex watch, very small. Only certain people can work on them. Guess what? They're worth thousands. The people that look at size of a robot to dictate product profit are looking at things incorrectly. I'm just telling you, if you have no idea of a product, start small, work from there. Case in point, we have a DMC2 mini desktop CNC. And the first and foremost area I always go to, because again, smoke and mirrors are everywhere. These guys want to blind you with footwork. Oh, I'm using the best linear rails. I'm using closed loop stepper motor servos. Bullshit. You know what that means? The servo, henceforth the stepper, actually just tells you it has an error. I've already shown you last week in my previous video showing we can run 200 kilohertz, what that actually dictates. Nothing other than the fact that now the motor is letting you know it's error. If we just stay away from the error and it doesn't happen, guess what? You don't even need it. So we're looking at the back of this system, and we can see here he was nice enough to shoot the internal electronics in case everyone wants to know. Of course, this system is not actually having a panel removed. It has what looks to be a clear plexiglass panel over it. And I already get the feeling that I'm looking at a gaming computer. And I'm going to tell you what I think about that. I've been into gaming computers for years and years, and I'm working on an Alienware system right now. I'm going to tell you the guys that need to pay the closest attention are the ones that are into gaming computers because of the fact a CNC robot is not a gaming computer. Okay? It's nice to be able to see your internal electronics. It's better to see the internal electronics built correctly. Let me explain. As we go through this, and we'll play this portion of the video right here, and I'll let you hear exactly what this owner of the channel, which is Sheriff DMC, this is his YouTube channel. We'll play it and let you hear him explain about the electronics used in the system. We'll cover some things.
Motor drivers, and coolant electronics. We've made significant ease of use improvements here as well with an updated breakout board that has diagnostic LEDs for power, signals, button states, spindle output, and basically everything I/O related at a glance to determine if something is functioning or not on the electrical side. This makes troubleshooting very straightforward and simple. We don't usually see problems with the DMC2 electronics, but there is always the chance for human error when...
All right, guys, let's look at this because, of course, he was nice enough to zoom in. If we come over here, the first area of concern I see is right here. And what I'm looking at is I see shield exposed. See that? And these cables that are going in here to these servo slash stepper error encoder drives, what we're actually looking at is no connection from that shield going anywhere. Okay? Look at this carefully, right here, right here. All of those cables are the same. I mean, all of this with the black sheathing, we see all of this, and we see right here shield exposed, but it's not going anywhere. First of all, it being exposed at all is a general no-no. If I received a system like this, it'd be going right back. I would not even take a chance. As we look carefully at this system and we cover it more in depth, we're going to see another major no-no. Because again, if we have shields because we are using the proper double shielded cable, we don't know if this is double shielded. We don't know anything other than we see a shield there exposed. Shielding should never be exposed, ever, ever. Meaning, unless you're doing a direct connection, it should be insulated to that ground bus, and that's it. That's best practice, and that's the safest principle to work with, because again, if God forbid there's ever a shop fire or a fire in general, your insurance you want to get paid with. You do not want to have a problem where they're going to question the fact why this was built that way. These guys seem to forget that. They don't understand what actually happens in the U.S. pending there's, God forbid, a fire. And it does happen. What we see here will draw a major red flag. Let's continue. We'll go through this briefly.
When you're connecting and wiring things up yourself, and maybe 1 in every 100 people who are building the kit might cross a wire or swap two things accidentally. And before, that was annoying to track down with a multimeter, but now it's as clear as just an indicator light to show if something is not where it should be or not.
Now that is interesting. I have to give him an A+ for being innovative. I love that idea. He put LEDs that if somebody connects something incorrectly, those LEDs would indicate, hey, you need to fix this. That's genius. I'm not even kidding. I think that's a fantastic idea. The issue is taking it to that level, yet missing something as basic as connecting our shields properly in a system, or insulating shields that are not used properly using the proper heat shrink, makes me wonder. So as we continue this,
Not outputting the signal that it's supposed to. Speaking of electronics and wiring, we've made massive improvements to the kit building experience here too, and now all of the low voltage electrical wires are pre-stripped, pre-made connectors, which makes assembly go way faster. And
okay guys, you see this right here? This is a USB input. This is your breakout board. Just to be clear, so that everyone understands exactly what I'm about to tell you. USB sucks. It's complete bullshit for use with CNC. Okay? If we're using any type of spindles that draw at least 110 volt, you should not be using USB. If a system is in excess of $2,000, you should never see a USB breakout board being used. I'll say it again. If any system, complete with controller, is in excess of $2,000 in a small format frame, and when I'm saying small format, I'm going to say any system under 24 inches wide, any system square under 24 inches, they should never be using a USB controller if the price point is $2,000 or above. Ethernet right now is cheap enough that they should always look at upgrading the system for maximum stability. That's number one. When we look at this, we see all of these leads going into this breakout board. And to make sure everyone understands, your breakout board is the essential brain communicator between your PC and your drives. So regardless of how great your drives are, if this board is not correct in terms of how it's built, in terms of stability, meaning we make all of our electronic wiring properly shielded, properly filtered, so that all of those step and direction signals are going there, regardless of the best drives being used and all the servo bullshit, you're going to have a system that's unstable. Fact. Fact. So don't be blinded by just the chassis. The chassis looking nice, having a nice enclosure around it. I mean, they go all out on things they understand. It's where they don't understand things, you've got to be careful. And like I said, it's the details that count. The control of the system is the area of concern you're worried about the most. And I cannot emphasize that enough. Guys always think the electronics is the easiest. I don't know how that is. And then they look at my channel and they're like, wow, all these videos. And then he has the sub rating he has. Well, he's a great bullshitter. I mean, he must be a fantastic bullshitter. All this feedback on eBay, yet we see this, and I see this being done all the time, and yet my videos become redundant. Hey guys, jump over to eDealers Direct Automation and check out my eBay store for the components used to make what you see in this video, as well as many others that you may not even realize you need. Of course, I'm always there if you have questions. Message me and I'll get back to you as soon as possible. And of course, I do custom engineering as well as consultations. Thank you for watching this video and your support. Take care. We have to look at that. We have to look at it. This has to be looked at in a format that you are trying to get the most stable platform you can. Using USB is not it. Balzas over at CNC Drive, lead engineer of the UC100 USB motion controller. I've said this probably in 100 of my videos. I've had a direct dialogue with him explaining disconnect issues many of my clients were having. You can read from him what he's responded with. And when you read all of the issues that go on with USB, which I know are fact because I've had way too many clients confirm this. See, I want to be very clear that when I say something, I'm not saying it in theory, guys. I'm talking hands-on use. And if we go back in history on my channel, I've got 17 years on YouTube. I've got at least, I think, 20 on eBay. If you think about that cumulatively, I don't know many people in this field that have that. And I'm being truthful, look it up. So think about what you're seeing here. As we go through this, let's check it out in depth.
And all of the other wire for everything else like the power supply, spindle buttons, etc. are all pre-measured, stripped, and pre-soldered. So you just stick them where they need to go and screw them in. This simplifies everything and saves you hours of time and effort. The spindle motor uses high flex double shielded and grounded oil resistant cable and is intentionally routed separate from any low voltage signal wires in the electrical cabinet so that electrical interference is not an issue.
First of all, he can say electrical interference is not an issue when every person that he sold the system to justifies that. That's a very, very strange thing to say unless you've sold so many systems and not one client has had a problem with EMI, which could very well be the case. The issue is if we don't follow best practice, and we're using an inferior control system as USB, Universal Serial Bus, knowing all the instability issues, you guys are playing essentially with fire. So once again, and I cannot say this enough, just because your system is stable today, tomorrow, the next minute, the next second, and it's completely random. That's why I tell you details count. It's better to eliminate variables from the beginning than to build them in the system and chase them at the end. It's way more costly. People that understand this genre realize this from the beginning, and that's why their systems cost what they do. When I see something like this, once again, the idea of putting LEDs if some client decides to connect something incorrectly, I think that's a great idea. Seeing him use a USB breakout board that's probably 20 bucks on a system that I believe is in excess of $2,000, guys, that's ridiculous.
The DMC2 Mini ships with an economical off-the-shelf 5-axis Mach 3 controller board, and the reason
USB, there's your controller right there. Economical. Economical naturally means cheap. If we're going cheap, we're also dealing with cheap signal transmission. You tell me what you want. So where does the system matter? Doesn't matter about your high wind rails, doesn't matter about your linearity, doesn't matter about your closed loop steppers if the signals are fucked. I mean, I can't say it any better than that. If you can't get the signals from your brain to your feet, who gives a shit if you're wearing Nikes? Right? Your money on any CNC should be spent symmetrically. So when you're looking at something to buy, make sure that the chassis matches the controller quality. If the chassis exceeds the controller quality, move on. If the controller quality exceeds the chassis, move on. I've seen guys literally, and I know this sounds crazy, I've seen guys literally take a $2,000, $3,000, $4,000 controller, overbuild the controller to making it basically a spaceship on a wood chassis. Use common sense, okay? we need to start executing common sense. If you're unaware of where to spend the money and how to spend the money, symmetrical spending is best. The chassis matches the controller. 2,000-3,000 on a chassis. If I'm going really balls to the wall, excellent. 2-3, and I'm talking about a chassis this size to be concise. The controller to control that chassis, same price, fine. Less than that, get less than that. Make it symmetrical. The closer to symmetry you have in both, you'll have an ideal system. Now, I get a lot of guys that want to go shopping on Facebook. Has taken over where guys like to shop with good reason. A lot of the prices are really good. I'm going to go local to me, and I found this place called Arc CNC Plasma Tables. I see a lot of these guys pop up. I see them pop up, and he's got pricing here: 5x12, 15.5, 5x10, 13.4, 4x8, and so on and so forth, right? And then he does videos on it. And then we start looking at the pictures. And this is where, once again, guys get that awe-inspiring moment. They look at it and they're like, man, it looks so nice. Look at this table. This is just gorgeous. It's powder coated. Everything looks great, right? But every now and then we get lucky. And here's why we get lucky. Every now and then they throw a picture in of the controller. You said it. So we come over here, and I'm going to cover some of the things in these pictures I've noticed right away. Again, we see he wants to show you that he's outputting a lot of volume here. He's got a big warehouse. And we're going to keep going. And guess what? Here's our controller, right? Well, I can't zoom in on Facebook. So what I did is I go over here, and I actually put it on my desktop so we can check this out. And we look here carefully as we zoom in. And there's a lot of things going on here. First and foremost, we see jumped leads on his motor drivers, okay? We also see dual power supplies, which already tells me he doesn't understand basic electronics in the fact that one power supply is more than sufficient for a 4-axis drive system. If he understands how one power supply can supply the normal amount of amps required by these drives. You wouldn't put 2 in because you're just doubling the amount of EMI, electromagnetic interference, you're introducing to the system. The other thing is that we come over here and we look at our GX16s and nothing is insulated, meaning there is no heat shrink on any of these connections, guys. What do you think your insurance company will say if there's a fire about that? You think they're going to say that's acceptable? No, they're not. I'm telling you right now, that's scary. I will give him an A+ on selecting a UC400 for Ethernet control. Maybe he saw some of my videos. I don't know. But if he did, he didn't watch the ones that instigate him using a Proma. And just to be certain, this is a Proma. You can see the text right there. We'll go back to his listing where it confirms it. But do you notice that the Proma is installed in the controller? This is interesting. We see a lot of these guys do that. They think they're doing it right. They're making everything neat. But you know what it's telling me? And it should be telling you. They didn't do their homework. This system is built incorrectly, not just because of the dual power supplies, not just because he's jumping leads over here, daisy chaining, not just because nothing is filtered in here. I seriously doubt there's a ground bus. I don't see it. We could see his E-stop here has 2 leads going to it, which also instigates daisy chaining. But where things get interesting, really interesting, is when we look over here at this SD model Proma, and why he's not using a THC 150 is using an IDS system, individual drive system, in which case he would have to use the SD model Proma to support it. The THC 150 is designed for integrated drive. The SD model is step and direction. That's what it stands for. Here is the manual for the compact THC SD from Proma. And as we scroll through this manual, I want to point out some things that are super important to understand when integrating a THC in your system. First and foremost, it says here, when connecting directly, meaning to the plasma system, which all of you will have to do, use the shortest possible cables for connecting the plasma source with the THC controller. It is recommended the THC controller to be located directly at the plasma source. You know what that means? That means that this box right here, let's just zoom in a second. This torch height control system right here should be mounted on the plasma unit itself, because what happens is we have a differential in voltage. And why is that important to understand? That differential in voltage that's present, it will instigate those two relays that are inside this system, sending signals to either elevate your z-axis or decrease the z-axis height, that you will find it will actually vary. If it varies too much because of that voltage being inaccurate, guess what? Now you've got a THC that's inaccurate at a much higher level. Now don't get me wrong, THCs are never 100%. They're never 100%. Anyone saying it's bullshit. Okay, so don't believe that they're all 100%. They're not. They're probably around, on a good system, probably around 90%. Okay, overall though, this is a major, major screw up on his part. Okay, but it gets worse. Let's keep going. Now this is direct from the user's manual from Proma. So if this gentleman built this system correctly, when I say correctly, understanding the electronics he's working with, would that have even been an issue? Are you okay spending upwards of $13,000 for this system knowing this? How much did I just save you guys? Even if you asked him a question on what I just showed you, how much did I just save you? Right. Let's keep going. Let's keep going. As we come down, right here, okay, you can see here that we have more or less interweaving of our wiring going to our step and or of our directions. And you can see this as an individual drive here. It's got the direction plus, direction negative, step plus, step negative. You look at this and you notice that these wires are twined, and that's to mitigate EMI. It's not as effective as passive filtration with a ferrite, and it's certainly not as effective as double shielded cable, but it does mitigate a slight form of EMI. It's not 100%. But as we come down, this is where things get interesting, even more interesting. To reduce the possibility of short circuit entering the CNC system, the connection should be made with a shielded cable. The shielding must be connected to grounding on the CNC system side. Do not connect the shielding to the THC controller side. So once again, and I'm going to zoom in here, how much did I just save you? How much did I just save you? If this guy is watching, what do you want to bet me he changes his system? If he's a smart guy, he would. He should call me up and thank me. Either way, what I just showed you here shows you that this system is not built correctly. And this is exactly where we go with this. As we look at these systems and we keep looking at the ones that do not make any sense, where once again, there's not anything here with shielding, nothing. All he did was integrate this in the controller to keep it clean and once again, make things easy. And when I say easy, easy on his eyes, easy on your eyes, doesn't mean he understands what's going on. So be careful. And I say that to you guys, and I mean it wholeheartedly. Be very careful. Let's continue this journey looking at this system. Once again, we have his video, we have his cuts. Now we're going to look at the chassis, and we're looking at this, and just to reassure all those out there who may get butthurt because of what I'm showing them, here's this picture once again that I can zoom in on, and you can see there's the Proma inside the controller. You can see it right there. There it is. So looking at this, we know now that that's completely screwed up. We do not want to do that. And then on top of that, we look at this chassis. And many of you out there go, man, it's powder coated. It's beautiful. How do you ground a table that's powder coated, guys? It's non-conductive. Wait. Let's check and see. Powder coating is an insulator making poor ground conduction on a plasma CNC. Yes, powder coating is an electrical insulator and will cause poor ground conduction on a plasma CNC. Did I say this? No, actually, this is AI overview. This defines the amount of research that needs to be done to make sure they're building things correctly. I mean, if you don't know, the resources are there. So I'm asking you again, would you spend your $13,000 with this guy? Does he have your best interest in mind? Oh, wait. They'll tell you things like you get unlimited tech support. You get this and that. We're going to give you free tires. We're going to give you free lug nuts. How about you just build the chassis correct? And when I say the chassis as a whole, the entire chassis, meaning the controller too, you have to really put time in to understand shielding, grounding, EMI mitigation, dealing with different voltages, the safety of different voltages. That's why you hire someone that does that. That's why in your house you don't have a plumber doing electrical work. You have an electrician. It's the same principle. These guys don't practice that, guys. And when I say this, I've said this over and over again. What I just saved you on this one overview of this system on top of that DMC2 system, you guys can tell how much money you've just been saved without asking these questions to the person that's building your system. And this is why consultations to people that are validated are essential. When I say validated, guys, look for social validation. I'm going to tell you something differently. How many guys out there have hired someone for their business to find out that they're not even qualified probably to run a lemonade stand? I'm just saying the truth. 80% right now can't have an attention span past 15 seconds. We've seen studies on this. Yet we have people claiming on LinkedIn they have a resume like this, and they're building plasma tables, but the plasma table itself is built beautifully. The controller isn't. So why not just sell the plasma chassis itself and not the controller and outsource them? That's a great idea. That's a smart man. Think about what I said. I hope this video has been helpful. Be careful and have a great Labor Day. Take care.